Alright, and welcome to the Quadratic Formula. Now, this is a video I really wanted to take my time with, and I want y'all to take your time with it as well. What if I said, hey, I want you to solve f of x equals x squared minus 16. You might say, hey, Mr. Hastings, I know for a fact that is a difference of squares. We can factor it down into x plus 4 and x minus 4. Notice we know that because 16 is a perfect square. Yeah, and you would be right. And then you would say, okay, well, x is equal to, let's see, the opposite of positive 4 is negative 4, and the opposite of negative 4 is positive 4. And so our solutions would be negative 4 and positive 4. Now that is if we have something easy. But there's another method that we can use to factor this, and we can actually use this for every single type of quadratic. So if you're going to ask, Mr. Hastings, why are we doing something so complicated when we have such a simple way to solve this one? Here's my reason. We're going to start with an easy example because the quadratic formula is hard the first time you see it, and I want it to be as easy as possible. All right, now we're going to do 3 examples, and it's the third example where you will truly need the quadratic formula. But let's learn this together. So what is the quadratic formula? Get ready, deep breath. It is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now you might be thinking, I will never be able to learn how to use this, but I promise you this. If you try this, and if you work through it, and you fight through this, and you can do this 10 times through, whatever 10 problems you're going to have to do with this, you will become so good at this, this might even become your preferred method for solving quadratics, because this works for every single type of quadratic. Let me demonstrate. We know here our a term is 1. We see that there's no x, so we can assume that b is equal to 0. And this is our constant, this is our c term. So what I would always have you do is I always like to tell my students to memorize writing this with nothing but parentheses in place of every single letter. Okay? So everywhere I have a number, I write the number. Everywhere I have a letter, I write a parentheses. Okay, let's go through and let's use different colors here. We said that there's no middle term, so b is equal to 0. So everywhere I see a b, I put a 0. We see that a is a 1, so everywhere we see an a in the formula, we put a 1. And lastly, let's just go ahead and use c here. We know that c is negative 16, so here I'll put negative 16. Okay, now the first way I tell students to start solving this is always do the outside, inside, bottom. Okay, what do I mean by that? Well, here is the outside, and wait, negative 0 is just 0. That's not even there. Okay, perfect. The next thing I would say to simplify is the inside. And what do I mean? I mean the inside of the square root. Now I'm going to kind of bring this on up here. And what's that going to look like? Well, that'll look like x equals plus or minus the square root of. We know 0 squared is just 0. And here, I would always ask you to count the negatives for these 1, 2, 3 terms. And we have 1, 2 negatives. Well, negative times a negative is a positive. And you don't have to write the plus sign, but I just want to demonstrate that our final answer will be positive. Also, we have 4 times 1, which is 4, and 4 times 16, which is 64, all over, and here is the bottom. Remember, we're going to solve, or we're going to simplify the outside, inside, bottom. 2 times 1 is 2. Now, we are literally almost done. Check this out. We know that the square root of 64 is 8. I hope you would know that. So we really have plus or minus 8 over 2. I just took the square root of 64. It's 8. And this is really 2 things. It's positive 8 divided by 2, and it's negative 8 divided by 2. Remember, when you see a plus or minus, it means there's 2 8s there. There's a positive and there's a negative 8. And 8 divided by 2 is 4, and negative 8 divided by 2 is negative 4. And you'll notice we just got the same exact answers that we did when we factored this and solved for it. And even though this looked kind of crazy, it still wasn't that bad. All right, I would suggest you pause the video, take like a 5-minute break if you need it, come back, come watch example 2. Let's move on. Okay, in example 2, we have g of x is equal to x squared plus 5x plus 4. Now, what if I said, you know what, there's an easy way to solve this. I'm simply going to factor into x plus 4 and x plus 1. And I know that it's 4 and 1 because 4 plus 1 is 5 and 4 times 1 is 4, and that's easy. And look, in order for this to be 0, x is literally just the opposite of positive 4. So x is negative 4, and x is the opposite of positive 1, so negative 1. Hey, and you're like, Mr. Hastings, that is insanely easy. Well, what would this look like using the quadratic formula? And remember, we don't need the quadratic formula for this one, but I want you to be introduced to the quadratic formula when it's nice and easy. So we have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and what was my first tip for you? My first tip was to start by solving this by setting every single letter into a parentheses. So negative parentheses plus or minus the square root of parentheses squared minus 4 parentheses parentheses all over 2 parentheses. Okay, let's plug in everything that we see. I'm going to put all my b terms in purple. So there's b, and my b term here is 5. So I'll put a 5 right there, put a 5 right there. Okay, let me use a nice little orange here, and I'm going to use orange for my a terms. And what is my a term? Well, my a term is 1. So let's see, that's an a term, that's an a term. I'll plug in 1, and I'll plug in 1. And lastly, you know what? I haven't used green in a while. Let's use green for my c term. And my c term is green, and I plug in 4. Now remember, in order to begin solving this, I want to first start by tackling the outside, the inside, and the bottom. And what would that look like here? Well, I would have x equals a negative times a positive is negative 5 plus or minus the square root of. Here I have 5 squared. 5 times 5 is 25. And here, check it out. I only have, for these 3 terms, I only have 1 negative. That means with 1 negative, our final number must be negative. Now 4 times 1 is 4, and 4 times 4 is 16. All over my bottom 2 times 1 is 2. Now you'll notice that here inside the square root, this is not fully simplified. So whenever there's no 0 term in there, I would just say this simplify the inside again. So sometimes you'll have to simplify the inside twice. Now what is this going to give us? X equals negative 5 plus or minus the square root of, and 25 minus 16 is 9, all over 2. Now hopefully you know what the square root of 9 is. Okay, so the next thing we always take care of is our square root. And the square root of 9 is simply 3. Okay, and so the square root of 9 is 3, so we write plus or minus 3. Now one mistake students will do here is they'll write the square root again. They'll write the square root of 3. No, that's not correct. You're taking the square root of 9, so the square root symbol is completely gone. And what are we really saying here? We're actually saying that this breaks down into 2 different things. There's negative 5 plus 3 over 2, and there's negative 5 minus 3 over 2. So let me really highlight this in green. Plus or minus 3 really means plus 3 and minus 3. There's 2 things there. Now a lot of y'all can do 2 steps at once in your head. That's fine. But for this, let's be very careful. Negative 5 plus 3 is negative 2 over 2. And negative 5 minus 3 is negative 8 over 2. And when we go to simplify this, negative 2 divided by 2 is negative 1, comma, and negative 8 divided by 2 is negative 4. And check it out. We have our original 2 answers. And it took us a lot longer to get there. But it's in the very next example that we'll need to actually use the quadratic formula. So follow me along. And guys, do not quit on me. Do this third example. Take a break if you need to. Okay, here we have our third and final example. And this is where we truly have a use for the quadratic formula. Okay, here we have, and you always want to do this. You always want to label your A term, you want to label your B term, and you want to label your C term. And let's see, what is our quadratic formula? Well, it's negative b plus or minus the square root of b squared minus 4ac all over 2a. And you have to memorize this. You have got to memorize this. I promise you, millions and millions of students will memorize this formula this year. You are no exception. You can do it. Now remember, what's my first tip? My first tip is for you to replace all of the parentheses, all the letters with parentheses, because then it just becomes very easy to fill in. Now, why do we have to use the quadratic formula? What's the benefit here? Well, whenever we have these decimals, there's really no way for us to factor this. So the quadratic formula just becomes a quick, easy way for us to solve this problem and to see where x actually crosses the x-axis. Okay, so I'll start with my a terms, and I'll use those in purple. So let's see, a term 2.5, and a term right here 2.5. Okay, let's use my b term in orange. We have a positive 5. We have a positive 5. Oh, that's familiar. And lastly, let's go ahead and use this green for our positive 12.2. 12.2. Now from here, we'll of course simplify the outside. Negative times a positive is negative 5, plus or minus. And now we'll simplify the inside. We know 5 squared, 5 times 5 is 25. And here, remember, when you look at these three terms, always count up the negatives. And notice there's only one negative. So we'll write minus, and I would use a calculator to multiply those three numbers together. So I'll go ahead and use a calculator. Let's see. 4 times 2.5 times 12.2 will give us 122. 122. All over, and 2 times 2.5 is 5. Okay guys, I paused because here was the mistake that I made when writing this problem. I had intended for this a term to be a negative 2.5. So here's the deal. I don't want to reshoot the video, so here's the only changes we're going to make. Our original problem, we're going to make that a negative 2.5, which means we're going to put a negative 2.5 there and a negative 2.5 there. And guys, check it out. A negative times a negative is a positive, and a positive times a negative is a negative. And now this problem is exactly like I need it to be. My apologies. If we had continued, we would have had 25 minus 122, which would be a negative. You can't take the square root of a negative number. That would have meant no real solutions. Okay, but we avoided this crisis. I caught my mistake, and here we go. Now we have x equals negative 5 plus or minus the square root of, and guys, 25 plus 122, remember we simplified the inside again, is going to be 147 all over negative 5. Now from here, remember this is where we take the square root of 147, and this will be the first time that we get a decimal. So the square root of 147 is going to give us 12.12. And guys, this would be one of the few times where I would encourage you to use a decimal over a fraction, all divided by negative 5. Now, I'm going to circle our plus or minus in green, and let's really illustrate this. Plus or minus tells us we have two things here. We have negative 5 plus 12.12 over negative 5, comma, and our second solution is going to be negative 5 minus 12.12 over negative 5. Now from there, this should be pretty straightforward. Okay, so we're going to simplify the top here. Negative 5 plus 12.12 will give us 7.12. Oh, I'm sorry. Sorry guys, it's a little late. I apologize for these mistakes. It will give us 7.12 over negative 5, comma, and here, negative 5 minus 12.12 will give us negative 17.12, once again, over negative 5. Now, I'll write my final solutions right here. I would use a calculator for this. 7.12 divided by negative 5 will give us negative 1.42, and negative 17.12 divided by negative 5 will give us positive 3.42. Alright, and there you'll have it. That is how you use the quadratic formula to solve for the x values, the x-intercepts, the solutions, the roots to any quadratic that cannot be factored. Alright, I'll see y'all in our next video.